That's what you do, right?
Now I'm going to talk about linear equations. And I promise you, when I do this today, I'm going to do it, very systematically, simply, so that if a person didn't know how to do this, they could. And I say that because some people, might not have done math in grade 12, 13, whatever, they might be ready for school for a while, they might not even like math. They might think a linear equation is completely a horror. In fact, almost every year when we do linear equations, I have students who, I can see go completely white. They don't want to do this. They freak out by it. But I will argue to you, to such people, that this is simpler than demand and supply. I will show you that you'll do better on this, even if you know nothing about linear equations, than you do on shifts in demand and supply. This is beautiful stuff. We're going to do it, okay? So, what we're going to do is, now we've talked about shifts in demand and supply, but I want to say to you, there's many reasons for us to use some kind of equation of demand and supply. Now, the simplest equations we can use are linear equations. But though they're simple, we can get everything we need out of them, first of all. Secondly, linear equations are the calculus means of approximating nonlinear equations. So in small changes, a linear equation is good enough for us. And also, linear equations have other decent properties for us. So even though we can always use a linear equation as a first approximation of whatever's going on in the world. So we're going to do that. And here, basically what I do is I talk to you about linear equations, the slope, this and that, and I'm going to give you some more. But the beginning here is this. A linear equation always is in the form of y equals a plus bx in that form. There's no exponents. We don't have any squares or cubes or square roots or anything like that. And it turns out this format will define any line in two-dimensional space. So again, for most of you know this stuff. For those who don't, this is the review. In a two-dimensional space like this, if I have this line like this, at this slope, it defines that line with the slope. And the slope is the rise over the run. The slope is always right there. It tells if x changes, how much y changes, right there. Right? But also you'll notice if I had that slope at this board, I could have an infinite number of lines. So I need to set the line in space. And we do so by giving it an intersection with the y-axis right here. That's the A. So that's all we need. You say the A is 5, and the slope is 1. There's the line. A straight line. It defines it. Okay? As we saw before, there's the line, there's the slope, there's the intercept term. Okay, then the solution is we have, as we saw, where do we have this here? We have two lines intersecting here. And it turns out that, as a simple thing, if you have two variables, to get a single unique solution, linear system, you need to have two what are said to be linearly independent equations. All it means is the equations can't be parallel to each other. You want to visualize equations on the board. Those are equations, those are also lines. So the theory says you can't have two linearly dependent equations, that is where they're multiplied to each other. On a diagram, it means they can't be parallel to each other because they don't intersect. And of course, they have to intersect in positive space for us. They could intersect in these other quadrants down here, but we want them intersecting here. All right. So, demand and supply, since they're not parallel, usually will intersect in positive space right here, and we'll get a single solution. Right? So now, there's a mathematical way about doing this, but we don't even need the math. We know at equilibrium, the quantity demanded equals the quantity supplied, and the price demanded equals the price supplied, right? That's the market equilibrium. That defines market equilibrium. That market equilibrium, QD equals QS, and or PS equals PE. So therefore, when I give you these two equations, like this, now it turns out everybody, you'll notice, but again, the first time you see this you may not, I won't tell you that this is demand in any way, shape, or form. Nor will I tell you this is supply. I'm just going to give you two equations, as I'll do in a minute. But you'll know this is demand. Why? Because it's negatively sloped. And you'll know this is supply. Why? Because it's positively sloped. Everybody? So you'll know. And this says, PD, the most that anyone would pay for this particular commodity, Q, this whatever this commodity is $120. And then if the price fell by 2 cents, or in this case 20 cents, because we're talking dollars, one more person would buy. If it fell by 20 cents, if it fell by $1, 5 more people would buy. So that's all it tells us, right? That's the Q goes down by, P goes down by 2, and Q goes up by 1. Q goes up by 1, P goes down by 2. Here, this says the least cost that a firm can produce a unit is $30. But as more units are produced, it costs 10 cents more for every additional unit. That's what it says. Okay, good. So here we go. I must tell you, there's only one rule about eating in this class, and what does that mean? I don't care if you cannibalize each other. It's not my concern. My concern is if noise is made, okay? No crinkling, ever, ever, ever. No crinkling. Okay, good. So, here we go. I'm going to make this up. P equals 240 minus 0.3, actually I'm making 0.3 Q. And P equals 40 plus 0.02 Q. These are the demand and supply functions. So let's see this now, but let's follow here for the moment. I'll get rid of this in actually in a minute. Suppose I ask you to draw it. You would draw it like this. What is the intercept, or why the price intercept for demand? What is it? 240. So this would be here. And suppose I drew it like this, just for sake of an argument. I can figure out exactly where we intercept here over the supply, but I don't care. Supposing I drew it like this, right? I just drew it like that. That's demand. Now the other is D, and then this is D. The other has an intercept of price of, I think it's 40, which is here, right? So I'll just put here, like this, and you would draw it. And now I've got only one question for you. The demand function was 240 minus 0.03 Q. The supply function was 40 plus 0.02 Q. So the slope of one of them is 0.02 positive, and the slope of the other one is minus 0.03. This is minus 0.003. So tell me which one you think is most likely. Do you think this should be supply? This should be supply. Or this should be supply, and give me a reason. Which is the most accurate reflection of supply? Given its slope, you want to think in terms of relative slopes. Yeah, go ahead. Yeah. Now this is going to be very interesting for us. For the moment we're not interested. But I'm going to get there later. It turns out we're going to be able to do some really good shortcuts. Simply because of this. We can actually say, notice here, this one here is quite steep. This is probably 0.05. This one, notice, it kind of bisects. So it has roughly, this is going down by 0.03, this is going up by roughly 0.03. If they have the same slope, they would cut this right in the middle, this intercept right here, would actually be, there's 200 difference, it would be 100 split 140, right there. So that's kind of useful to know. Supply is not as steep, it looks like this. So right off the bat, I see price is going to be less closer to the supply price than it is to the demand price. Now that turns out to be interesting, as we're going to subsequently see. You can see, for example, if supply was really flat, price is going to be, there's going to be a big quantity, the price is going to be relatively low. And if supply is really steep, it's going to be a little quantity and price is going to be very high. So we'll get to that. The actual, we'll just draw this like that. We're good. A little bit more like this. Okay, good. Then, next. So we proceed like this. Okay? Like this. All right. So here we know PV equals PS. And as I say, normally, at this stage, and only this stage in the class, this is the demand. The quantity demanded is a function of the price that's out there for demand. The price supplied is a function of the quantity supplied, like this, or quantity supplied is a function of the price supplied. Now we know at equilibrium, PV equals PS, and of course, QD equals QS. So if we want to solve this, we just say 240 minus 0.03 Q, and I don't have to say QD because it's the same Q for both, equals 40 plus 0.02 Q. That's all we need. Now, it turns out that's mathematical, but it's also economic. We know at equilibrium, the quantities have to be the same, the prices have to be the same, so we can do that at equilibrium, right? Okay, good. Now then we're going to solve this. And I was just saying that to the other class. This is what I saw. You know, I grew up with what used to be called the new math. Now it's probably called the ancient math. But the math that you guys grew up with, I saw it in a grade 8 textbook or something, or 9 textbook explaining this. I couldn't believe my eyes. I freaked right out. Because it showed this. In all its wonder, it showed. This is what happens, it said. It showed this. It went like this. Literally had this, like this. Right? Now this is absolute junk. Total and utter junk, mathematically. It's okay if you know what you're doing, you don't get freaked out by that. But this is not smart. Why not? Because it doesn't make people understand what they're doing. It makes people poor at math. This is an equation. An equation, both sides balance. Like anything else that balances, if you add, subtract, divide, multiply, square root, take the log of, you can do anything to one side as long as you do to the other side. That's the rule of equations, right? You can do anything, but you have to do it to both sides. So therefore, what you actually do when you do equations is, you subtract the same thing from both sides. In our case, I'll add, in our case. I'll do it, I'll do it like this. Plus 0.03 Q. And over here, I'll add the same thing. Now I can totally do that. That's totally and utterly legitimate. Now of course, for most of you, anyone can do this. But when you get to logs and exponents and stuff like that, you forget the rule and you start screwing around. But if you do the same thing to both sides, the same operation, you're going to be cool. So anyway, this gives us then 240 equals 40 plus 0.05 cubed. Then we do the same thing again. We subtract 40 from both sides. 240 minus 40 equals 40 minus 40, giving 0 over here, plus 0.05 cubed, which gives us 200 equals 0.05 cubed. Then we divide both sides by the same thing. In this case, 0.05, and divide this by 0.05, and our answer is Q equals what? 4,000. Good. Because you can do that in your head, right? Good. That is pretty good. But most of you can't. So therefore, when you can't do it in your head, what do you use? You use a calculator. Which means yesterday you should have had your calculator out. So get it out. Let's get going. I'm going to tell you that if I could strike you with lightning bolts after this exam, and I will tell you that in this room, people are going to lose marks because I say to use your calculator, you sit there and stare at the room. And it comes to the exam, and you can't even use a calculator. And you certainly can't use it in a speech. So, what you need to be doing, I can lecture here completely abstractly, but for me, it's all about doing it. You do every example I give you as fast as you can. You don't worry about the example. You don't copy this stuff down, unless you really don't have the background, you might remember it. When I give you the example, you get the answer. Bang. That's how you get good. The rest, nowhere. Okay, good. So Q is 4,000. Okay, now, what's our next thing? What is the price? How do we find the price? Well, how do we find the price? Plug it in. 240 minus 0.03 times 4,000. Now, by the way, I don't even know if 4,000 is correct. I mean, it seems to be for my calculations. Who knows? I might have been distracted. So, what price have we got here? 120, because 0.03 times 4,000 is 120. Now, here's the thing, and this is why you guys got to learn to love equations. You're going to make mistakes on shifts in supply and demand. And actually, when you walk out of the exam, I'm going to say to you, did you get that right? Like part D of shifts in supply and demand, like an increase in income, an increase in the price of a substitute. You might say to me, not sure. You might be right. You probably got it wrong. You know, that's typical. But I'll say, did you get this right? Your answer will be wrong. What will your answer? And I'll say, how much money do you want to put on it? You'll say, I'll put every penny I have because I'm absolutely correct. And how are you absolutely correct? I want you to be absolutely correct. How do I know I'm going to be absolutely correct? Huh? Check it. How do you check it? Put it in the other one. So again, those of you who might not like math, that's one of the things you do. You don't take advantage. You don't check it out by putting it in the other equation. So you get it wrong, you're completely baffled. Everybody mathematically makes mistakes, possibly, but then when they plug it in, they find their mistakes, because this is 40 plus 0.02 times 4,000. This thing here is 80. 2 marks. It's done. It's done. You can torture me, and I know I've got it. You know, everybody. So there's no screw-ups. This is absolutely correct. Okay, everybody. Good. Then on the diagram, we're going to have this. Now notice price is a little bit less than the median. 240 and 40 right in between is 140, but the price is actually 120. All right. Now then, that's 2 marks of this third question on this exam. And this is 4,000. So we're going to have a price for it. Let me see. What does it matter about this? Let's have a price for okay, we're going to have a price floor of $150. Notice there's a price floor of $150. And diagrammatically, you all know how to do this. You would find at $150 the quantity supply and the quantity demanded. And again, you have to forgive me, because I work with a lot of students who can't translate, and the key element here is you don't have to know anything about the equations. Translate what you do with the diagrams into the equation. I want this number, and I want this number. How are we going to get them? Diagrammatically, it is, I find the line, the equation, the quantity demanded at 150. On supply, I find the quantity supplied at 150. Good. And then the difference is surplus of what? So my question to you is for two more, well, first of all, P equals 150, price floor, max price. What is the quantity demanded? Answer. For another market, this example. Good. Thank you, Heaven. I was thinking I had to phone up some grade 8s and ask them what the answer was. That is seriously slow. Well, who's the answer? Who has the answer? And the rest of you, why not? I'm just saying, I'm trying to figure it out. I was maybe saying to you, I don't have it here, but in some of the lecture halls we have a document camera, which I could actually tilt up and takes pictures of the document. What's the gives you the computer, but it's literally a camera, so I can turn the camera and focus it on people in the class. And when I actually go around an exam, I rarely see anybody who looks dumb. Now, why is that? But when I ask questions like this, and I see lots of them, if you saw yourself, you go, "Oh my God, I don't have a brain in my head," or a cell in my head. Now, what is the difference? And the difference is this. Surprisingly, a thinking person has something other than a look of total terror, which is what half of you have. You just look, no, think about it. Two advantages. Number one, you might get the answer. And number three, if someone looks at you, you look intelligent. Otherwise, you don't. And this is not good. In an interview, for example, if someone asks you a question, you need to think about it, because if you don't, you will get dumb. Maybe only part of it. Everything. So start thinking so you don't look down. Okay, good. Because literally you do. I should take rows from here. You guys sit over there and watch these people. Because you'll see it. I'm trying to give you a big secret in your life. Try to think. It has many, many advantages. Okay, quantity demanded. What happens here is 150, because I can probably type it out faster than you guys can do it. 240 minus 0.03 QD, so Q equals 90 minus 0.03, and the answer is 2,700? 3,000, okay, good, got it. That's what we want. Now that I want to know, what is the surplus or shortage? Quick, don't piddle around, just do it, bang, bang. So we can talk like we're on top of our game. What? $2,500. How did you get that?
Calculated quantity supplied and subtracted it.
So it turns out we've got quantity supplied by 150 equals 40 plus 0.002 Q, which we found Q equals 110 divided by 0.02, which is 5,500, and the surplus, this is the quantity supply, equals 5,500. Is this what you got? Minus 3,000 equals 2,500. Good. Guess what, people? There's 3 more marks. Can you believe me? I mean, have you ever met such kindness in all your life? Right? I'm giving you this stuff. So do not screw up. Now, it turns out this is good, because now you're actually being serious. let's see now. I now want to know, first of all, I want to know, what is the consumer surplus at equilibrium? Can you figure that out for me? What is the consumer surplus at equilibrium? First of all, do it on the diagram. See it on the diagram, and then figure out how to do it mathematically. Yes.
It's,
Before you calculate it,
5,000.
just tell me how to put it in the diagram.
it's the triangle, it's going from 240 to 120 to 1,000.
Okay, everybody, so you look at this and you see it is this triangle above the price line, which in this case is 120, below demand because you're getting all the consumer surplus for each of the units that are sold, the people who buy them, like that. Now I need that area. That being a triangle, it's half the area of a rectangle, and so, we can probably do this right here somewhere. We're going to have the consumer surplus being a triangle is base times height divided by 2. The base is what? The base is, in this case, what's that? Oh, 4,000. 4,000 minus 0 times the height, which is 240 minus 120 divided by 2, which is, sorry? 240,000. Okay, good. That's consumer surplus initially. What is consumer surplus? Call it 1, right? At the, I'll do it like this, at the price floor, like that. What is the consumer surplus at the price floor? It is then this, right? And what is that consumer surplus? So that's going to be 3,000 minus 0 times 240 minus 150 divided by 2. What is that number? What? 135,000. Okay, so then, what is the loss of consumer surplus? What's the loss of consumer surplus? 105,000. Good. More marks for you guys. Okay, tell me another way of calculating that. If you were double checking, how would you do it? How would you do it? How would you double check if that's the change? Yeah. The loss and the profit.